Alrighty, and welcome back. So today we are going to be able to jump straight in to the last section that you'll need for the take home, which is going to be solving systems of differential equations. This is section 4.9 if you're keeping score, 4.9. And yeah, we saved the best for last. Um, yeah, you'll see these can be extremely long, as in 2 pages or more long per problem. So that's okay. We're going to have fun with this. If you like some of the minutia of DE, you're going to absolutely love this section. So here we go. Let's say that we're going to start off with an example. I don't have any homework to go over, so I can jump straight in. Makes me so happy. So let's say that we have x double prime plus 2x prime plus y double prime equals x plus 3y plus sine t. And then let's leave some space. X double prime. Oh, wait, you know what? Let me just do one and then go with that. I don't know why I did two on that. All right, so what I'm going to do now is put this in standard form. Okay, so all the x's and y's need to be over on the left, and all the functions of t would be on the right. So I'm going to wind up with x double prime, so x double prime plus 2x prime minus x. So I'm getting all of my x terms grouped together, and we'll do the same with the y. So plus y double prime, and there's no y prime, so I just go straight to minus 3y equals sine t. Alrighty? So now that I've got it into this form, I'm going to use the differential operator. Do you remember that with the 4.1 theory? So y prime is big D of y double prime is d squared y. Y'all remember that? Yay, I hope so. So now I'm going to translate this into the differential operator. And it's going to look a little strange because there's going to be a differential operator in front of each of these x's. So I'm going to go ahead and factor out the differential operator. So I'm going to have d squared plus 2d minus 1 x plus d squared minus 3 y equals sine t. Okay? So, as you can already see, this starts to look more like a polynomial. What is a polynomial? But it looks like something that we might want to manipulate. We have done things where when we were talking about the auxiliary, we factored and solved and done things like that. But now we're going to actually use this notation in a completely different way. We're going to solve systems of differential equations using the differential operator through the process of elimination. And I'm sure that y'all remember elimination back in linear algebra days, where if I have, I don't know, x plus 2y equals 3, and maybe negative 2x plus y equals negative 1. And the way we would do elimination is we would multiply each of the equations by some value if needed, so that when I added the two equations together, one of the variables would be eliminated. So in this case, if I multiply the top one by 2, I'm going to wind up with 2x plus 4y equals 6. And then I just add these two together. So the x's are going to cancel. I'm going to be left with 5y equals 5, y equals 1. Then I take and plug that into one of my original functions and wind up with x also equal 1. I made something simple so I could actually do that in my head. So that's how we solve system equations using elimination. And that's what we're going to be doing now, except we're going to be using the differential operators as our coefficients. So this is going to be pretty cool. I think you'll like it. Let me erase this. Let me increase the size of the eraser. That's not big enough. Alrighty, so here we go. Let's say that we have, let's do a real simple one to start off with. So dx dt equals 3y, and dy dt, I wish I could, yeah, I can do it that way. dy dt is equal to 2x. We're going to solve this system. Let's first convert it into differential operator notation. So I'm going to wind up with big D, capital D, x minus 3y equals 0. And notice I've kind of put it into a standard form where x and then y. And for the second one, I'm going to wind up with 2x minus dy equals 0. So if I want to put my first terms together, the x's together, I moved this one over rather than moving that over. You could have done either one. It matters not at all. So this is totally fine what we have right here. And so I'm going to drop out the y's. And the way I'm going to eliminate it is I'm going to multiply this one by d and this one by a negative 3. So if I do that, I'll have a negative 3dy and then a positive 3dy. And when I add them together, I'll be able to eliminate the y variable. So what do I get here? Well, I multiply every term by d, so I get d squared x minus 3dy equals 0. And negative 3 gives me negative 6x plus 3dy equals 0. Okay? So now when I add them together, I'm going to get something kind of cool. D squared x minus 6x equals 0. But I can now take this. This is x double prime, right? Because the d squared. If I convert this into an auxiliary equation, I can then say, well, that's the same thing as m squared minus 6 equals 0. M equals plus or minus root 6. So for my x's, x of t equals, and both x and y are functions of t. So that's something to keep in mind. So x of t equals c1 e to the negative root 6t plus c2 e to the positive root 6. Well, I have to do a positive sign. To the positive root 6t. Alrighty, so that's my x of t. But we're not done. All we've done is we've solved for x. Now we need to solve for y. And you can do kind of a substitute back in, I guess, but don't do that. You're going to wind up with some very non-friendly things if I try to plug this solution in up here with the primes and the double prime. Don't go through all that. What you should do instead is start the same process over again, but solve in terms of try to eliminate the x's instead of the y's. Okay, so I'm going to erase, let's see, I'm going to erase, really all I need to erase is this part right here. So we're going to erase this, what we're multiplying by. I'm going to keep this x of t solution and just kind of figure out a place to do scratch work maybe up here. Alrighty, so what I'm going to do now, if I want to drop the x's out to eliminate them, I'm going to multiply this term by maybe negative 2, this equation, because that would give me negative 2d. And if I multiply this by d, I'd get positive 2d. And so I'd wind up with the x's eliminated. So what would I get? So negative 2dx plus 6y equals 0. And then down here, I'm going to get 2dx and minus d squared y equals 0. So now when I add them together, the x's are going to be eliminated. I'm going to have, if you allow me, I'm going to swap the negative sign around. I'm going to wind up with d squared y minus 6y equals 0. It doesn't matter. I'm adding them together, then I divide by negative 1 and you get the exact same thing. The 0 lets me do all that. So now that I got in this form, I'm going to wind up with my auxiliary as m squared minus 6 equals 0. Well, what do you know? M equals plus or minus root 6. Okay? So I get the same thing. Except now I'm going to get the following. Y of t equals C3 e to the negative root 6t plus C4 e to the positive root 6t. Okay? Now, these are my two solutions. I've got a solution for x of t and a solution for y of t. But in the process of getting that, I'm going to write my x of t right here where I can erase the bottom. Is equal to C1 e to the negative root 6t plus C2 e to the positive root 6t. Okay? So I have my two solutions here. And that's great. That's wonderful. But we have one last step. And that last step is to take care of all these constants. I've got C1, C2, C3, and C4, which is a lot. I don't want to have to worry about having 4 different constants because I notice that when I solve for my y of t and my x of t, the solutions were both negative root 6 e to the negative root 6t and e to the positive root 6t for both of them, right? So I can use that to my advantage to be able to solve for, here we go, C3 and C4 in terms of C1 and C2. Okay? So let's see how we can get this, how we can figure this out. What you do is you take either one of the original differential equations. It doesn't matter which one you pick. I'm going to pick this one. So I'm going to erase all of this stuff and take care of this. Okay? So I'm now going to plug this x into this x and this y into this y. Okay? So if I do that, I'm going to get the derivative of this stuff. Okay, so this is going to be, let's see, I guess I can put the negative root on the outside, doesn't really matter. So I'm going to have negative root 6 C1, and this is going to be e to the negative root 6t, okay, plus, let's see, I've got this part right here that's going to be root 6 C2 e to the root 6t. So I just did my x, the derivative of x is right here. And then I'm going to do the y part now. This is going to be multiplied by negative 3. So this is just going to be minus 3 C3 e to the negative root 6t minus 3 C4 e to the positive root 6t. Okay? Now I can group them according to their, and that's equal to 0. I can group them according to the exponentials here. E to the negative root 6t's are going to get grouped. So if I do that, I'm going to wind up with negative root 6 C1 minus 3 C3, and that's going to be multiplied by e to the negative root 6t, like so. And then now that I've got it into this form, you know what, let me do the other ones real fast so that I can say both of them at the same time. Now I'm going to do the C2 and C4s because those are both the positive root 6t. So I'm going to wind up with positive root 6 C2 minus 3 C4 times e to the positive root 6t equals 0. Alrighty. This can never be 0. This can never be 0, which means that these have to be 0. So now I can say negative root 6 C1 minus 3 C3 has to equal 0, and root 6 C2 minus 3 C4 has to equal 0. So what does that mean? Well, that means that when I solve out, oh, I hope I can do this. Let me actually make a little bit of room and redo that so that I can root 6c2 minus 3c4 equals 0. All right, so now I'm going to solve out. And when I do, I'm going to get the following. I'm going to get that c3 is equal to, is going to be negative root 6 over 3 c1, right? I just move that over and then divide by the negative 3, and so that's what I get. So I've got this substitution that I can make. And then for over here, I do the exact same thing, and I wind up with C4 is equal to, well, swing it over, divide out positive root 6 over 3 C2. Okay? So now that I've solved for my C3 in terms of C1 and C4 in terms of C2, I can now substitute those back into the C3s that are up top. Okay? So if I do that, my y of t is now going to look different. My y of t is going to be, well, C3 is negative root 6 over 3 C1 times e to the negative root 6t. So all I did is I changed the C3 into negative root 6 over 3 C1, which is what the substitution shows right here. And then plus C4, which is root 6 over 3 C2 times e to the positive root 6t. Now, these two are the final solution for the system. I've got my x of t, I've got my y of t, and they're in terms, both of them, in terms of C1 and C2, which is nice, because now I just have to worry about solving for two constants if I'm giving initial conditions, which you're not going to have enough to solve for all four of them, but I can solve for two of them. Alrighty? Woo! Now, just to recap, that was the work that was needed to do two first order linear homogeneous equations. You can imagine it gets much more interesting as we move to second order and non-homogeneous. So, woo, are you ready? Okay, let's clear this up. Let me get my paper where it needs to be, and we will start the next one. Okay, so let's say that we have x prime plus y prime plus 2y equals 0, and x prime minus 3x minus 2y equals 0. Okay, so we've got our two differential equations. These are not bad at all. So first thing we're going to do is convert them into the differential operator. So that's going to be dx plus, let's see, this is going to be d plus 2 times y equals 0, and then d minus 3x, and then minus 2y equals 0. So now I've got them all kind of boxed off like that. Okay, first thing, let's drop the x's. No real reason, just that's what I did on my paper, so that's what we'll do here. So to drop the x's, I'm going to multiply the top one by d minus 3 and the bottom one by negative d. Okay? And so if I do that, I'm going to wind up with top one by d minus 3, so this is going to be d times d minus 3x plus d minus 3 times d plus 2y equals 0. And then the bottom one, negative d times d minus 3x. And then it's just going to be plus 2dy equals 0. Okay? So now when I add them together, the x's are going to cancel. They're going to be eliminated. And I'm going to wind up with something that looks kind of strange. I'll have d minus 3 times d plus 2 plus 2dy equals 0. Alrighty, so how can I resolve that? Well, let's just multiply it out. This is going to be d squared, and then minus 3d plus 2d is going to be minus d, and then minus 6 plus 2dy equals 0. I can now combine the negative d and the positive 2d and get d squared plus d minus 6 y equals 0. Alrighty, I can knock that out. That's the auxiliary for m squared plus m minus 6 equals 0, which is m plus 3 times m minus 2. So my m is equal to negative 3 and m is equal to 2, which means that my y of t is going to be, let's see, I think I can put it right here. Y of t is going to equal c1 e to the negative 3t plus c2 e to the positive 2t. Okay? So now we're going to do the exact same process, except we're going to eliminate the y's this time. So let me clear all this. Get a larger brush size, make short work of it. Okay, erase the little factors there. Alrighty, so now we want to eliminate the y. So I'll multiply the top one by, let's say, 2. That sound good? So 2, and then the second one by d plus 2. Okay, so if I do that, I'm going to get negative 2, not negative, my gosh. Ooh, too big. Brush size was too big. All right, so I'm going to get 2d, okay, and then let's see, this is going to be plus 2d plus 2y equals 0. and then multiplying by d plus 2, I'm going to get d plus 2 times, that was an x, right? I forgot my x right there, times d minus 3 x, and then minus 2 times d plus 2 y equals 0. All right, there we go. I'm okay with that. So now that we've got that set up, I'm going to add them down, and when I get that, I'm going to get, if you'll allow me, d squared minus d minus 6 plus 2d x equals 0, which I know the 2d is going to make that a positive d, and I'm going to wind up with, what do you know, exactly the same thing. D plus 3 times d minus 2. And you can do the auxiliary if you want to, be very consistent. But the m's and the d's are exactly the same thing. It's whatever you feel comfortable with. A lot of the books will not use the differential operator to do the factoring for the solution. They will always go back to the auxiliary. I'm okay either way. It doesn't really bother me. 2 equals 0, which is m equals negative 3, and m equals 2, which means that we have for x of t, c3 e to the negative 3t plus c4 e to the positive 2t. Okay, so we want to get the c3s in terms of c1s and the c4s in terms of c2s. So pick one of your original equations. I'm just going to pick the top one. It makes no difference which one you pick. And plug in my x and my y to the top one. So this is going to give me the derivative of x, which is going to be negative 3c3 e to the negative 3t plus, I've got the derivative 2 c2 e to the 2t. And I think I'm going to run out of room. I should have compacted that. Oh well, I'll try. Plus, yeah, I'm going to run out of room. There's no way I can fit that all on. Sorry, let me try that again. This time I will compact it a little bit. So what I really need is for these guys to be in a different spot, but I think I can make it work. I just had to write a little bit smaller. Apologies if you were already having trouble seeing what I was writing. So here we go. I plug my x in. It's the derivative of x, so this is going to be negative 3 c3 e to the negative 3t plus 2 c4 e to the 2t. So that's the derivative of x. Now I've got the derivative of y. So I'm going to do plus, and the derivative is going to be a minus, so it's going to be minus 3 c1 e to the negative 3t plus 2 c2 e to the 2t, and then plus 2 times y plus 2 c1 e to the negative 3t plus 2 c2 e to the positive 2t. Woo! Alrighty, equals 0. So let's see. I'm going to gather up all of my e to the negative 3t's first. So this is going to be, let's see, negative 3 c3, that term's gone. There it is right there. I couldn't find the next negative 3t. Minus 3c1. Oops. Don't want to do an extraneous mark here. So that one's gone. And then this one right here, plus 2c1. And that's e to the negative 3t. plus, now that I've done that, I can do the C4s and C2s, so 2C4 plus 2C2 plus 2C2 times e to the 2t equals 0. Alrighty, so now I can set each of these pieces equal to 0. So negative 3c3, and then negative 3 plus 2 is going to be minus 1c1 equals 0. And then here I'm going to get 2c4 plus 4c2 equals 0. And so now if I swing that over, but I want to solve for c3 in terms of c1, unfortunately. But c3 is not going to be hard to solve for. Imagine swinging this over, it becomes positive c1, then I divide by negative 3. It's just going to be negative 1/3 c1, right? Okay, and so now for the c4, I do the same thing. C4 is going to equal, swing that over and divide by 2. I'm going to wind up with negative 2 c2. Okay, so now that I've got my constants, I can rewrite my x of t as x of t equals negative 1/3 c1 e to the negative 3t minus 2 c2 e to the 2t. And this is the actual solution we want. We want that x and that y, and we're happy. Alrighty? So as you can see, it's not bad until you get to the non-homogeneous part. Guess what we're doing next? Yes, we're doing the non-homogeneous part. So buckle up. Here we go. Let me clear this and let's tackle that one. I hope you're enjoying this so far. I know I sure am. So here we go. Okay, so here we go. Buckle up. This is one of the 2.5-page problem ones. So let's say we have x prime minus 4x and then plus y double prime. And that's going to equal t squared. And then we have x prime plus x plus y prime equals 0. So we're going to convert this to a differential operator. We're going to wind up with, what was that? D minus 4x and then plus d squared y for the second derivative equals t squared. And then for the second one, we're going to wind up with d plus 1x and then plus just a single derivative, so dy equals 0. All right. So what do you want to do? Well, I'm going to drop the x's out first. Not really any reason why. The y's are going to be easier, that's for sure, but I'm going to be difficult and drop the x's out first. I'm going to multiply the top one by, let's do positive d plus 1, and then the bottom one I'm going to do negative d minus 4. Okay? So if I do that, I'm going to wind up with, up top, I'll have d plus 1 times d minus 4x plus d squared times d plus 1 y equals d plus 1 times t squared. Yep, we have to multiply our non-homogeneous part as well. So now if I multiply through by the negative d minus 4, I'm going to wind up with negative d plus 1, d minus 4, x, and then plus d, oh, that's going to be a minus, isn't it? That is definitely going to be a minus, so minus d times d minus 4, y, and then that equals 0. The second one we don't have to worry about. Alrighty. Whew. That is a lot of work. So here we go. The x's are eliminated, and we have a very confused looking jumble for our y's. We're going to have d squared times d plus 1 minus d times d minus 4 bracket y equals, now this is the fun part. This is a differential operator. So what is the derivative of t squared? Absolutely, it is 2t. And then 1 times t squared is t squared. So this winds up equaling t squared plus 2t. Because when I do the d plus 1 times t squared, I'm going to get 2t plus t squared, and I just reordered it. Okay, so now let's get some of this mess cleaned up inside here. So this is going to be d cubed plus d squared minus d squared plus 4d equal times y equals t squared plus 2t. Okay, so this d squared and the negative d squared gone. I'm going to be left with d cubed plus 4d times y equals t squared plus 2t. Okay, so now that I've got it into this form, I'm ready to start factoring this, put it into the auxiliary form, and try to solve for it. Okay, so if I solve for it, I'm going to rewrite it up here. M cubed plus 4m equals 0. Factoring m out, m times m squared plus 4 equals 0. Now, I know m equals 0, but now I need to solve for this. So m squared plus 4 equals 0. M squared equals negative 4. M equals plus or minus 2i. Okay? So now that I've got this 2i part, I do not have a number in front, so my alpha, this is one of the complex solutions. So my alpha, if I can write it there, is a 0, but my beta is a 2. So that's good knowledge. So now I can do my solution. My solution is y. Where do I want to put my solution? Let's see. It doesn't really matter. I'm going to need to do a whole bunch of erasing anyways. Y sub c equals c1. I've got my m equals 0, so that's where the e to the 0t just becomes c1, plus c2 cosine 2t, that's the beta that we found, plus c3 sine 2t. All right. Now, what we have found is the complementary solution. We need the particular solution. So we need to do the method of undetermined coefficients and make a guess in order to figure out what will fit this t squared plus 2t. Okay? So I want to do one thing before I do that, and that's I'm going to put this into instead of the differential operator notation, before I go from a particular solution, I'm going to actually write that into the prime notation. So if you will allow me, I'm going to write that way, oh gosh, I have no room anywhere. I'm going to put it right here because I'm going to be erasing it anyway. So this is going to give me y triple prime plus 4y prime equals t squared plus 2t. Okay, now I need to make my guess. And if y'all are okay, I'm going to erase this and do my guesswork over here. So let me erase this. Alrighty. And I don't need this one either. Okay. So what do I want to make my guess? Well, just looking at it, we might say, well, I can just go to t squared and I'd be good. But I've got a y triple prime here. If I just do my guess as y sub p equals ax squared plus bx plus c, what's going to happen? Well, if I do that, I take the derivative, y sub p prime, 2ax plus b, y sub p double prime, 2a, and then y sub p triple prime is a 0. I get no information to plug in here. So instead of doing, and I did x's, I should have done t's because this is all functions of t's. Yeah, that's lag from all the other problems that we worked. What I'm going to do instead, though, I want something to survive to plug into this triple prime. I need more information than 4y prime. So what I'm going to do is start at an x cubed so that something will survive down here. So let me erase this and start over. I'm going to make my y sub p equal to, and these are functions of t, not x. So a t cubed plus b t squared plus c t, and then you can do plus d. That's totally fine. Alrighty. It's not going to matter because we don't have a y function here, so it's going to be gone, but that's okay. Now let's do y sub p prime. It's going to give me 3a t squared plus 2b t plus c, then prime, 6a t plus 2b, that was double prime, and then y sub p triple prime, 6a. So now I have something to plug in right here. So let's go ahead and do that. Let's plug in. So I'm going to wind up with, let's see, I think I can fit it in right here. I think I can. Let's see. We got y triple prime, which is just 6a, and plus 4y prime plus 4 times 3a t squared, and then plus, oh, it's times the whole thing, isn't it? Let me erase this little thing here. So 3at squared plus 2bt plus c, and then that's going to equal t squared plus 2t. All right. So now I can group things. First off, let me distribute that. 6a plus 12at squared plus 8bt plus 4c equals t squared plus 2t. Okay, so now that I got it in this form, I can group. Let's see. I'll start with the t squared. So 12a equals 1. Let's see, the t's now 8 b equals 2, and 6a plus 4c equals 0. Alrighty, so this means a is equal to 1/12, b is equal to 1/4. And let's see, so this is going to be 6a, so that would be 1/2 plus 4c equals 0. C equals -1/8. Okay, so now I have my y sub p. I'm going to erase this right here. So now my y sub p is, it's this form, right? So it's going to be 1/12 t cubed, and then plus 1/4 t squared minus 1/8 t. And my y would equal this plus this. That's my y of t. And I probably should write that down somewhere. I'm going to erase a chunk. I'm going to put it right here. Okay? That way I can erase everything below. So far so good. All right, let me write all that. So get a giant eraser. Maybe not too giant. Alrighty. So erase all this. Okay. Now let me rewrite it. So y of t is equal to c1 plus c2 cosine 2t plus c3 sine 2t plus 1/12 t cubed plus 1/4 t squared minus 1/8 t. All right, that's my y of t. That is not going to change. I am going to box it in. I am almost halfway there. Not quite, but I'm almost. Okay, so now I can erase this down here. Alrighty. So let's see. We dropped out the x's in the last one, so now let's drop out the y's. So to do that, I'm going to multiply just the bottom one by -d will do the trick, right? Yes, if I do that, I'm going to get, for the bottom one, let's see, I can do it right here. -d times d plus 1 x minus d squared y equals 0. So if I think about, I'm adding the top one to this one, right? So if I do that, I'm going to get -d squared minus d for this thing, and then plus d minus 4 bracket x equals t squared. Okay? So now I can kind of simplify this. The d's are going to cancel. I'm going to be left with -d squared minus 4x. So -d squared minus 4x. Well, I should probably put parentheses around that. Okay. Equals t squared. All right, so I'm going to solve the auxiliary. So this is going to give me -m squared minus 4 equals 0, which m equals plus or minus 2. So that wasn't too bad. That means that my solutions are, here we go, x equals c1 e to the -2t plus c. Oh, I'm sorry. I can't do that. Why? Because I've already used 1 and 2 and 3. So this can't be that. This has to be c4 and c5, e to the positive 2t. Okay? So now that I've got my the y sub c, or x sub c in this case, solved for, I can now take a guess. And one thing I could say, oh wait, I've done that wrong. Hold on. I've done that wrong. I just looked up and went, wait a second, those are cosines and sines, not e's. Hold on. Yep, I made a mistake. Big mistake. You saw nothing. This is what I get for skipping a step. This is m squared plus 4 equals 0. M equals plus or minus 2i. Same thing as we got up here. Aha. I was getting worried for a second. So x sub c is going to equal, we're going to have c4 times cosine 2t plus c5 sine 2t. Oh boy, do I feel better. Okay, that's good. Yeah, that was totally wrong. So now that I've got that, I can erase some of the stuff over here and start working on getting my particular solution. So for the particular solution we have to work with, I've got my, oh, I just erased it. Gosh, I wish I hadn't done that. It's not that big of a deal. I had negative, what was it? D squared minus 4 equals t squared, I think, something like that. And there was an x there, of course, x and an x. And so this is negative x double prime minus 4x equals t squared. I sure hope that's what that was. Okay, so if that's the case, then I've got, for this one, I've got a t squared here, and I only have the second derivative, the second, it's x double prime. So my guess can be x of p equals a t squared plus bt plus c. X of p prime is going to be 2at plus b, and then x of p double prime is just going to be 2a. Alrighty, so now I can fill all that in here. Okay, so I'm going to get negative x double prime, so this is going to be negative 2, let me shift it a little bit lower so I can go all the way across if I need to, negative 2a, and then minus 4 times my x, so it's going to be minus 4a t squared minus 4bt minus 4c equals t squared. Okay? If y'all are allowed, I'm just going to multiply everything by -1 to get this into a form I'm more familiar and comfortable with. So 2a plus 4a t squared plus 4bt plus 4c equals negative t squared. Yeah, that's much better. All right, now let's group terms. We'll start with t squared, so I'm going to wind up with 4a equals, well, -1, right? And then the t's, well, 4b equals 0, and then 2a plus 4c also equals 0, because I don't have a t term or a constant term. Well, this lets me know that a is equal to -1/4, and b is equal to 0, and then this is going to be -1/2 plus 4c equals 0. So C is going to equal -1/8. Is that right? Did I get that right? I've got A is -1, -1/4. I think that looks right. I'm just making sure because I've done some crazy stuff. It's easy to get lost in this stuff. 2 times -1/4 is -1/2. Shift that over. That is not negative. That is positive. Ah ha ha ha. Am I glad I spent the extra second? That is positive 1/8, isn't it? Whew, gotta watch me like a hawk. Here we go. So now that I have my coefficients, I can generate my particular solution, and that is going to be of the form x of p equals -1/4, and then my x of p is, it's t squared. Gosh, if I had good sense, that'd be dangerous. -1/4 t squared. The b is a 0, and then I just have the c, so it's just plus 1/8. Okay? So if you'll allow me, I'm going to write that under here. I'm going to erase all this work and rewrite this in the form of x of t. So here we go. Get rid of all this. Erase, 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 erase. Ooh, ooh, don't go crazy. Yeah, I have to do that. Very careful. Here we go. So x of t is equal to, we have C4 cosine 2t plus C5 sine 2t minus 1/4 t squared plus 1/8. Just like that. So this is my x of t. And I can now erase this. But as we both know, that's not enough. We're almost there, but we now need to solve C4 in terms of C2s and C5s in terms of C3s. So this one's kind of interesting. Take a deep breath. Let's get started. Here we go. So we need to pick which one of these we want to plug our x of t and y of t in. I can see which one is better just right off the bat. I do not want to do the second derivative. I'm going to pick this one. And it's a homogeneous one. I don't have to worry about something on the other side. So I'm going to pick this one and plug in. So I'm going to have the derivative of my x of t, which is going to be, here we go, -2 C4 sine 2t plus, oh, can I do that? Yeah, it's going to be plus 2c5 cosine 2t, derivative here, minus 1/2 t squared plus 1/4. That was the derivative. Now I'm going to subtract off, or rather add 1. So this is, so adding the original, so plus C4 cosine 2t plus C5 sine 2t minus 1/4 t squared plus 1/8. Okay, so that's this part. Now I need to add the y. So if I add the y, I can already see, I think I'm going to get in trouble. We'll see. The derivative of y. Maybe I won't. So now I do the derivative of y. So the derivative is going to knock out the c1 straight off. That's gone. And I'm going to have minus, I'm not going to be able to fit this in, minus 2c2 sine 2t, okay, and then the derivative of this term is going to be what? Plus 2 c3 cosine 2t. Derivative of this is going to be, what is that? Plus 1 4, what is that? 3 over 12 is 1/4, right? Is that right? Okay, so I've got the two derivatives taken care of, and now I have to take the derivative of this chunk. So this is going to be, I can add that right here. So plus 1/4 t squared plus 1/2 t and minus 1/8. And looking back, I did my derivative wrong here for the constants. 1/4 t squared, the derivative of that is 1/2 t. Let me make a nice small eraser, so that's just t. And then the derivative of 1/8 is gone. So this piece is gone. Just realized that I had done that. So here we go. Let's go ahead and take care of all of these constants, not constants, but the expressions of t, t squares, and all that. So minus 1/2 plus 1/2, minus 1/8 plus 1/8, plus 1/4 t squared, minus 1/4 t squared. What do you know? They all go away. Whew. Oh, and I forgot. Equals 0. So here we go. Well, that's what it is equal to, right? So now I've got all of this. Let's group the sine of 2t's first. So if I do the sine of 2t's, I'm going to have negative 2c4. That's this term. And let's see, plus c5. That's that term. Okay, and then where's the next one? Right there. Minus 2c2. And that is sine 2t. And now let's do all the cosines and cross through this one. I'm going to get, erase that, make a better paren. So 2c5, that one, and then plus c4, that one, and then plus 2c3. That sounds good. And this is cosine 2t equals 0. Alrighty, so now that I've got all my stuff together, I can solve for, what am I trying to solve for? I'm trying to solve for C4 and C5s in terms of C2s, right? And C3s. So here we go. Let's go ahead and work on that. So let's see. I'm going to solve for, yeah, I have a slight problem here. It's not a huge problem. It'll work out just fine. But I can't solve for C4 without having a C5 in there, and vice versa. So in either one of these, what I really have is a system of equations now. I'm going to rewrite this one underneath here. C4 plus 2C5 plus 2C3. Okay? So I need to eliminate either the C4s or the C5s first. I can do either one. How about we eliminate the C5s to start with? I can do that if I multiply the top by a negative 2. If I do that, I'm going to get positive 4C4 minus 2C5 plus 4C2. Okay, that's going to give me 5C5. The C5s, my lord, C4s, C4s. The C5s are gone, and then plus 2C3 plus 4C2 equals 0. So I'm going to wind up with, if I move the C3s and the C2s over, I get a negative, then divide by 5, I'm going to get C4 is equal to negative 1/5 times 2C3 plus 4C2. Okay? So now let's do the same process and eliminate the C4s. So let's see. I've got, let me rewrite that one over here this time and eliminate with this side. So this is up part. Had them lined up wrong. It's positive 1C5, C5 minus 2C4. And this is minus 2C2. All right, I'm going to multiply the top by positive 2. So if I do that, I'm going to get 4C5 plus 2C4 plus 4C3. And I'm going to add them together. That'll eliminate the C4s. I'm going to have 5C5 minus 2C2 plus 4C3 equals 0. And so C5, when I solve for that, is going to be C5 is going to equal, swing those over, they change their signs, divide by 5. I'm going to have positive 1/5 or negative, I'll do negative just to keep consistent. Negative 1/5 times, I'm going to wind up with negative, so 4C3 minus 2C2. All right, so that's my C4 and my C5. So I can now rewrite this in those terms. So let me erase what I have right here. Get a fairly large eraser. Making sure I don't hit anything. All right. All those extensive years training, doing art classes, really paying off right now with the control that I have. I failed every art thing I ever tried. So here we go. X of t can now be rewritten as negative 1/5 times 2C3 plus 4C2 cosine 2t plus, or rather minus 1/5 times 4C3 minus 2C2 sine 2t minus 1/4 t squared plus 1/8. And this is my actual x of t. I've got my x of t, my y of t. I am done. That is the answer, because everything's in terms now of C1, C2, and C3. Ooh, wasn't that fun? I know it sounds crazy, but I actually enjoy working those. That's actually fun to me. I think it's actually really fun. You can guess which type of problem you have on your take home. It's probably going to look something like this one rather than the first two that we worked. So enjoy. I hope you have enjoyed this. This is the last that you'll need for the exam. I'll be putting out a couple more videos over the next week to wrap up everything for the semester so that y'all be ready for DE2. But this was an incredible way to finish up things. So I will see you later. Good luck with the take home. Stay safe and take care. Bye-bye.